Alright, so today what we are going to do is we are moving on. I'm not going to talk over you. So I suggest you stop. Okay, we are going to move on. Yesterday we were doing graphing, slope-intercept form. Today we are going to solve systems by graphing. Solve systems of equations by graphing. Slope-intercept form and how to graph it. Let me know about yesterday's how to graph it. Okay. You'll get a little bit of review, so it's not that you have to do it. You do need to get it as homework thing. You stay after school, do it then, but you don't have to have it before you do this. So title is Solve Systems of Equations by Graphing. The essential question is, what are the 3 ways that 2 lines can be related? Vocab is systems of equations. I gave everyone graph paper because you will need some, which means you need at least 1 for notes and at least 1 for homework. You might need more than that. You probably will need more than that for homework. That's okay. You have extras in. I didn't really count. I just grabbed a bunch and dropped them on the table. So. Hey, so can you guys guess what we're going to be working with? Graphs and equations. We're going to have to graph equations, which is why we did our lesson yesterday about slope-intercept form. That's one of the easiest forms to look at to know how to graph. What has to be isolated? What has to be by itself?
The y.
There you go. For slope-intercept form, it has to be the y. Basically, what this is saying is you're going to have more than one equation. Systems of equations. So what are systems of equations? What would those be? How many equations do we need? Why at least 2? As S, it's plural. We have at least 2. So what systems are, it's a collection of equations, which means 2 or more equations with the same set of variables. And since we're working with graphing, we're going to have 2 variables. Most of the time, it doesn't have to be all the time. Most of the time, your variables will be the same 2 letters. Guess what they are? X and Y. So we are going to have equations with an X and a Y in them, just like yesterday. So what I mean by this is we're going to have equations such as Y equals X y equals negative 3x plus 4. And your whole job on this, tell me what x and y equal. That's it? If that's it, if you say it like that, it makes it sound really easy. Can you tell me what it is right now? X is not negative 3. Negative 3 is the slope. Y is x. Y is the same as x, but what is x?
Y.
X is 2.
X is Y.
X is not 2.
1.
X is not 2.
X is 0. X is 0.
One.
Okay, let's do this. So I want everyone to pick up one of your graph papers. What form is this in? What do we call this? It is an equation, but it's a very specific name. What about this one? What do we call this? That's not coordinates. What did you work on yesterday, guys?
Constant.
Slope intercept form.
Yeah,
These
that.
two are written in slope intercept form. They follow the y equals mx plus b. If that is slope intercept form, then on this first one, what is the slope? It is 1. What is the y-intercept? It is 0 because nothing's being added. By the way, boys, this is what you missed out on yesterday. Over here, what is the slope? Negative 3. And the y-intercept is 4. We're going to graph these two lines. Alan's a little bit confused, but we can't blame him. He wasn't here. Can anyone explain to him how do you know what the slope and the y-intercept are on both of those?
Y equals mxb.
What does m stand for?
Slope.
So whatever's in that spot is your slope. What does the b stand for?
And it's imaginary. Does it always equal 0?
Okay. If there's no b, it's 0. All right, so let's get to graphing. I'm going to use 2 different colors because we have 2 different lines, and both of those have to be on the same graph. So you have, I want a color that you guys can actually see on there. So y equals x, and y equals negative 3x plus 4, right? We're going to graph both of these. Again, what was the slope?
1.
What was the y-intercept?
0.
So what do we start at?
1.
Not
0, 1.
y-intercept. You start with y-intercept. So you start along the y-axis at 0. So you actually start at the origin here. Now your slope tells you how to move. If the slope was 1, write it as a fraction, 1 over 1. Which direction do we move?
1 up.
1 up.
Which side?
Right.
To the right. Go up 1, right 1. From that point, where do you go?
Up 1,
Up 1, right 1.
Up 1, right 1. You can make as many points as you want. You don't have to have 3, but you need as many points as 1. What do I want to see you guys use to make a line?
Straight edge.
A straight edge. Do I care where you get that straight edge from?
No.
No, as long as it's straight. Alexis back there just picked up the whiteboard. Can you use a whiteboard? Does it have a straight edge? Yeah. Can you come up here and borrow a ruler? To check the rulers, because I've had so many students over the years sit there and tap the wooden rulers on the desk that they're all dented up. They're no longer a straight edge.
Yeah, that's how long this bridge is. I like curvy.
That's why I get mad when people tap the rulers, because you're bending them and putting dents that are no longer straight. I use a pad of sticky notes.
I'm not using.
If you have nothing, if you do not have anything with a straight edge, take a piece of paper and fold it. You can use this. I can take over here and bend my paper over. There's your straight edge. Okay? We have one line, don't we? How many graphs do we have?
One.
How many slope-intercept forms do we have?
Wait, one.
We have a second one, right? All right. On the second one, what is our slope? -3. What is the y-intercept?
4.
So where do we start at? Up from the origin 4. 1, 2, 3, 4. Which direction do we go?
Down.
Y down.
Because
Negative, make it a fraction. -3/1. Down 3, and then which direction?
4 to
Not 4. Just look at the slope. Only the slope. Focus right here. If you go down 3, do we go left or right now?
Right.
To the right. You went down to get the negative. Now it's +1. To the right, 1. From this point, where do you go? Down 3. To the right, 1. You could have also gone up or +3 and then to the left or -1. Okay? Olin, you paying attention back there? Draw a line. You have to pay attention because I will graph for you only if you can tell me exactly where to place everything. All right, guess what? You just solved the systems. Where do you see those two connecting at? 1, 1. You have solved the systems of equations in your notes. It's 1, 1. That's where they connect. Any questions on that?
I took that.
The only thing different from today than yesterday is you have 2 lines. Yesterday, what you missed out on, you only have 1 line to graph.
So we basically make 2 lines, and wherever they connect that's what it is now.
So there's our solutions. But it's not always going to be that easy because do I make things easy?
No.
Well, I try to make things easy, but I give you more complicated stuff. So we got to look at another one.
Aren't you gonna teach us? You said yesterday you're gonna teach us about something about letters and numbers. Remember when it came up in the problem? I showed you.
Oh yeah, remind me after this then. Okay. Let's see here. Which other one do I want to do? Here's the problem. I got to think of one that will actually work out the way I need it to. Okay. Ooh, that's a good one. Let's do another one. We're going to solve the system of equations with a y equals -x plus 1. And the second one is going to be y equals -x minus 3. Okay? First, slope-intercept form. What is the slope? Negative 1/1. What is the intercept? 1. So where do we start at?
Down up 1.
Up from where?
From the origin.
From the origins, go up 1. Now what?
Down 1, right 1.
Why down 1, right 1?
If you go from the model, you go.
Because it's negative. What if I wanted to go up 1?
Then you go to the left.
You go up, you go to the left. Make it a negative slope. Okay? Alan, look. Doing like this. Anywhere like this, that's positive. Whatever could be x. There'll be in your notes. All right, so go ahead, play connect the dots. And then what? Then what? Do the other one. What is your slope?
-1.
-1 over 1. What's your y-intercept? Positive 3 or negative 3?
Negative.
Negative 3.
Why?
Is that a 5 or no?
Because the x,
That's
the
S.
x doesn't count against the 3. It's negative.
Negative 3. So where do we start at?
3 down, 3 down.
3 down from the origin. 1, 2, 3. From that point, where do we go?
Down
Down
one,
1.
right one,
Right down and right 1.
because negative goes down.
What if I wanted to go up 1?
Go up one and then left one.
Then play connect the dots.
Okay, let's be graphing with
I'm just having like a war.
the parallel, yeah.
Uh-oh. For the parallel, what does that tell us?
That we can have.
What's the solution?
Goes
No, nothing.
The solution is where they intersect. So what is the solution?
undefined.
So in our notes, we're going to put y equals negative x plus 1 and y equals negative x minus 3. No solution.
You can't put an
No solution.
Yes.
It's really that hard to write out no solution.
No. Or right intercept, right intercept.
Huh?
Right.
So no solution. Why is it no solution?
Because they don't intercept.
They don't intersect. The solution is when they intersect. If they do not intersect, there is no solution. Okay?
Is that all we do, right? Homework. Let's go.
Let's do another one.
Why is she smiling like that?
Because I want to do another one. Because I like this one. This one's fun.
May I have your attention, please? The following students need to report to the office at this time. Manuel Hernandez, Jordan Harris, Arturo Guerrero, Stephen Gray, Sonia Gracia, Hillary Gomez, Dallas Garcia, Jamie Flores, Sergio Montelongo, Kimberly Moreno, Sabina Munoz, Erica Ortiz, Abraham Paredes, Tomas Ramirez, Luis Rivera, Rita Rodriguez, Malia Schultz, Jose Taperia, Zachary House, Miguel, Jamie Loya, Jasmine Mike, Eric Mercado, Manuel Mateo, Frida Civis, Santana Castañeda, Jenny Bernat, Jesus Bañuelos, Carol Aguirre, Celeste Moreno, James Nordyke, Lindsay Perez, Daniel Rios, Rosalie Luciaga, Luz Tercero, Miguel Hernandez. Those students need to report to the office at this time. Thank you.
All right. Can we graph both of these? Right as they are?
Oh, wait, what?
What is your slope for this one?
1.5.
What is your y-intercept?
-1.
Negative 1. So look at the other one. What is your slope? Why not? Because the y is not by itself. So this is just like an equation. We get that y by itself. What is on the side with the y?
Or X.
The x. Is it a positive or a negative x? What's the inverse?
Negative.
So we subtract what?
-1.
Are we going to take 2 minus 1x?
No.
Why?
They're not.
You can combine them both.
One has a variable, the other does not. So these cancel out, and we now have negative 2y equals and negative x plus 2. And I do have to apologize because I never really showed you guys this, and you have a problem like it from yesterday's homework.
Yeah, I got it.
Okay? Here's how. Is the y isolated? It's not by itself? What's with it? Is it adding, subtracting, multiplying, or dividing? Multiplication. What's the inverse? So we're going to divide by negative 2, but it's not just that. You have to divide by negative 2 and divide by negative 2. Each term has to be divided by negative 2. You have to do it this way. That way you get your slope and your y-intercept. If you just put one big line and you had negative x plus 2 all divided by negative 2, what's your slope? And what's your y-intercept?
A different one.
You can't figure it out. If you break it apart, because this is dividing both of them, now you can get it. Because, cancels out, y equals, negative and negative make what? Let's make this a fraction. It was 1x, so make it a 1/2 x. Plus, what's 2 divided by negative 2? Negative 1. So what is our slope? 1/2. What is our intercept?
-1.
So as Alan said, it's the same thing, right? So we're going to graph it, right?
Actually, it's not that hard.
So we have our,
I'm confused on like, yeah.
hey guys, that's a sure way to get me upset is you are not confused on everything. You got confused at some point, I will agree on that, but you are not confused on everything.
Just got confused on like when you're dividing by 2.
Okay?
You want to make the x.
You want to know why we divide everything by 2?
Yeah.
Because otherwise you guys would have normally said divide the left by 2, divide the right by 2, right? You just did that, you get that amount, right? Correct?
Yeah.
Are you guys all okay with that? 2 has to divide negative x plus 2. If you get that, can you divide a negative x plus 2 by a negative 2?
No.
Why not?
It's very much.
One's a variable. You can't take negative x plus 2 because of the variable. You cannot divide because of the addition sign in it. So we separate this divisor into 2 parts. It's dividing both the negative 1x and the 2. That's why we separate.
Okay.
Does that make more sense now?
Yeah. So basically, you don't have to do anything with that x. You just have to put it over. Like, if you just put it 1 and just put it over.
Okay, so now we're going to graph it. Where do we start with this one? And what is, we start with the slope? What do we start with? The y-intercept. Where is the y-intercept?
You need
From-
to solve that, or
Origin.
do you need to solve that because they're exactly the same, so you're doing the same thing.
Okay,
So you need to.
yeah,
Really?
yeah. Okay, now what do we need? What's the slope?
1/2.
So how do we graph the slope of 1/2?
The y is the negative and the x is the negative.
Good, so from this point, where do we go?
1 up,
1 up?
and 2 to the right.
Good. From this point, where do we go?
1 up to the right.
Good. And yes, I fully agree with you guys. If we plot it, we'd still get these exact same points and we'd get that exact same graph. So here's the question. What's the solution?
All of them. All of them. That's not.
What numbers? How many numbers are there? Infinity, so guess what?
Unidentified.
No, it's identified.
Then what is it?
Infinite, you put
Not finished.
identified.
I gotta make sure I'm spelling this right. Hold on.
No,
I know you put it.
Infinitely. Did that say infinitely? Infinite.
Infinitely many solutions. Which means any ordered pair you pick, if it's on one line, it's on both lines. Every solution that solves one solves the other. So our first example, there's only one solution that will solve both of them. Our second solution, nothing will solve both of them. Our third solution, if it solves one, it solves the other. So back to our essential question. What are the three ways that two lines can be related? One solution, no solution, infinitely many solutions. There's your essential question. You guys think you got this? What part are you mostly confused on? So you confuse it this step right here, so? I'm coming to you with that. As long as I know exactly where you step, and you don't tell me I can keep my phone. Alright, so there is one more example that we need to work with. Go ahead. No. Decimals and fractions won't matter. You're going to solve them the same way every single time. But what else do you guys struggle on?
Word problem?
That's what we're going to do.
Word problem.
So let's turn to the student page, and you are going to write this word problem down. Because Miss Lobemeyer is just mean. And I am pulling this out of the book, so I'm not picking on anyone.
Amanda.
With your pain? For what?
I knew it. And from the book.
Instead of just reading it, why don't you write it?
We have to?
Yeah.
An example.
I really am just reading this out of the book, by the way. Amanda, you better be picking a very good gym if you have to pay that much a month.
Yeah.
Actually, it's only $2 a month, but she has to start off for $100. There is.
Oh, it's the ABC one.
Oh, I hate these. I hate these.
Hey, no, AB. On this one, the ABs are literally write the equation, B is graph it and solve it.
Really?
A is write the equations, B is solve it.
What is C?
I read through every single problem I'm giving you today. That's what it is. There's no C.
That's good.
I think it's the ABC.
Why don't you give us a C?
I remember there's a problem where he gave me those A, B, C, and D.
Yeah, the last A, B, C, D problem I remember giving you, A was solve it, B was the same answer as A, C stated that they were the same thing.
And then D was.
And D was explained.
Yeah, but
I knew something
it's
was
simple.
here.
We tried, it's like,
One gym membership can help with all.
All right, so when I make you start writing more word problems in your notes, you guys can't complain now. Because you're complaining about the homework ones, and it's confusing you, so that means I gotta do more in notes, which means you have to write down more word problems.
You can only do that if it's part of the problem and we answer it and it counts.
Oh, I'm sorry. Say something, guys.
what?
It was so far down, you could barely see the bottom line. And not seeing the bottom line is not an excuse to not do the problem, I'm still making you do it.
That's really tough.
What's really tough?
This problem, like I can't write it.
Why?
Let's see it.
Alrighty. You guys ready? Do you have it all written down yet?
Yes.
I can't help you until you got it all written down. Alright, so what does letter A ask for us to do? 3, 2. What does letter A ask for us to do?
Write a system of equations.
Write a system of equations. System means how many equations are we going to have? 2 or more. How many people are we talking about in this problem? So how many equations are we going to have? 2. All right, so we are going to write one for Amanda. And we are going to write one for Maria. So let's focus in on Amanda. What is Amanda doing?
Hey,
Paying a fee of 100 and a month fee of
She's paying a one-time fee of $100 and a monthly fee of $10. Do we know how long she's going to the gym?
No.
Do we know her total cost?
No.
So we do know, what do you think is the total cost, the X or the Y? Why do you think the Y is the total cost?
because it's like everything all together. It's always the front.
So my problem yesterday, it was the Y.
Y is the total. So what is X?
How many months?
The months. That goes for both of them. I don't care if we're talking about Amanda or Maria. They are both talking about total cost and months. So we're going to write this out. Amanda, to get her total cost, we have Y equals. We have to follow that form of Y equals MX plus B. It will help us so much on this graphing. What would M represent? How much she pays per month. The one-time fee only happens once. The slope is multiplied into the X value, which means it happens multiple times.
Look at the $10.
So the slope is the $10. And then you put X, because it's $10 for every single month. Plus 100. There you go. You've written one part of that system. It's a system because we need 2. Now we got to look at Maria. What does Maria do?
$20 a month.
She pays $28 a month. So what do we start with?
Why?
20x plus what? Why 0? She doesn't have to pay any extra. She just pays flat out $20 a month. There's your system.
Amanda got scammed.
And now what do we got to do?
No graph.
We have to graph it. So let's go ahead and graph it. Our 2 systems are Y equals 10x plus 100. It is also Y equals 20x. Is this graph very big?
No.
How are we going to get 100 on here?
You can.
You wanna count by tens?
Count by tens.
That's what they say.
You count by tens, there's still work, because there is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Guess where our first point is gonna go? There's the 100. Okay, from there, what do we do?
Count number one.
Huh? Yep, it's a 10 over 1, our slope is 10 over 1, but how are we gonna graph the slope? We can go 10 up,
Go down.
go down where? Down 10, and how many actual lines is 10?
Oh, it's over.
1. Okay.
Oh, I
And then what did you have to go right?
yeah, well, I say we do one.
So that tells us that if we're doing this, the y value, the y-axis is counting by tens, the x-axis is counting by ones. Okay? That will work. You can do that, except for, I will promise you, we're still running into a problem. Because there's a slope, right? Now let's look at Maria's. What does Maria start at? The 0. The origin.
Trash.
What's the slope? 20 over 1. So what do we have to do? Go up 2 over 1. Are we going to be able to see where these intersect? No. So is this a very good system for solving? I mean, we can, but is this a very good graph to use? No. Do you guys see this nice white yellow thing over here?
Oh, no.
This is my pack of just completely different graph papers. There is one folder. That's the graph you guys were using. I think we should probably go through and use.
Oh, yeah, you should be stuck. It's identified already. We know. People who are watching it look at it. It's going like this, right? I mean, eventually it's gonna be up like that.
I think we should use these. It's not quite a coordinate grid, but it is a grid. It'll work.
I have a notebook that has a pen and paper.
Okay. So let's try it on this one. Do you see any axes on this? 3, 2. Do you guys see any axes?
No.
No. So we're gonna have to make our own. But let's look back at the other one. Where are these going to meet at?
No.
In quadrant 1, 2, 3, or 4? Quadrant 1. So do we care about the other quadrants really?
No, they're not.
I'm gonna say that, you know what? This right here
It's a quadrant.
all quadrant one.
on the very edge, that's my Y. I know you can't really see it because I just drew it in black over that, but that's my Y. That's fine. And which means this bottom
X.
is my X because I only care about quadrant 1. Okay? From here, can we do it? Do we have to count by tens? Do you have 100 lines?
I don't know. 1, 2, 3,
Right.
4, 5.
You can count by fives. I'd actually still count by tens because did you see how far these were apart? Still? I'm still going to count by tens. So here's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. It's going to keep going. If you choose to count by fives, that's your choice. I'm not going to count you wrong just because of how you count. As long as you keep it steady. Okay? But the x-axis, what do you want to count that one by?
10.
You still want to count by tens?
One.
The denominator's all 1. Would that be a very good idea to count by tens?
No.
No. So let's count by ones. I did, but I also skipped the line for that. You can skip count. I can count by 2, 4, 6, 8, 10, 12 as long as I'm leaving space for it. That's fine. Or you can make it look really crowded and just put those in. That's a good way to do it. Okay? Either way. All right. Are we ready to try this graph again?
Yes.
So, for Amanda, where do we have to start?
What are the 100?
At the 100 on the X or Y?
Y.
On the Y. Now this one, can we show a 10 slope, a slope of 10? On this graph, can we show a slope of 10?
Yeah.
Yes, not like the last one when we had to back it up. Let's go up and over. This one, I will admit, I don't think my one little pad, small pad is going to work. I'm gonna get my big pad out. I'm gonna get something with a longer straight edge.
Oh, that. The book.
It's not a book.
Oh.
It's a pad, a paper. It's a really thick pad of paper.
No, that is a book.
She likes the paper. But let's see it on here. Yeah, that's a book. Yeah. That's a
Pad
book.
of paper.
Into a book form.
It does.
Alright, there's a slope. Can we extend it if we need to?
Yes.
Yes, it doesn't have to go all the way unless you need it to. So now let's look at Maria's. What does Maria's graph start?
0.
At, what is that called?
1.
At the origin. And what is her slope? Her slope was the 20. So go up to the 20 and over 1. Each one, just go up 2 over 1. And then graph that, like connect the dots. Students always complain, I don't let you guys have fun in here. I'm gonna let you play connect the dots all the time.
Oh, yes.
In fact, I encourage you guys to play connect the dots all the time. Do they intersect now? Can we finally see a point where they intersect? Can we finally find this solution?
May I have your attention, please? We have new Apache shirts for $15. Please come by the office if you are interested.
What is the
Eighth grade
solution?
basketball shirts are $14. Please come by the office to pay. Last day to order is tomorrow, January 18th. The 2018-2019 yearbooks are on
Not
sale at
11.
the office. Purchase yours before they sell out. They are $30 from now until March 1st, $35 from March 1st to March 31st, $40 from April 1st to the end of the school year, and they are $25 on parent-teacher conference night. Our students from last semester, please
What does
stop
that
by
tell
Mr.
us?
Rick's room to pick up any artwork
What does the
that
tail
was
represent?
displayed in the display case. Just a friendly reminder.
Is that your X value or your Y
starting tomorrow,
value?
any items such as
Your X, what
backpacks
does X
and notebooks
represent?
left stored and sitting on top of the lockers will
What
be
does
brought
X
to the office
represent?
and treated as lost and found.
Month, so 10
Everyone
what?
come to our Seymour Rogers game night. It will be Thursday, January 24th from 6:30 to 8:30. Concession stands will
What
be
does the
available.
200
Bring
represent?
games to share, and there will also be games provided. Come and have fun with all the Seymour Rogers
Total
staff.
what?
Attention,
Not
SRMS
total months,
will be
total what?
hosting a talent show in March.
Total
If
cost.
interested in
So in 10
participating,
months, how
please
much is
stop by the
Amanda
office
gonna
to
pay?
pick up an entry form. May the following students come to the office
In
at
10 months,
this
how
time.
much is
Luis
Maria gonna
Aguilar,
pay?
Gina Gutierrez, Edmundo Leiva, Mia Mendez, Joseph Oliveros, Jaden Perez, Carlos Salgado, Gerrit Huerta, Angel Nunez, Alexis Acevedo, Alexis Amancio, Eddie Godina, Alex Lopez, Michael
There you go.
Mendoza, Gavin Moon,
That's how
and
you
Emily
explain
Wade.
them.
Those students need to report to the
Any
office
questions?
at this time. Thank you, and remember, it's a great day.
Sorry, but with Reflex Math, we don't have time for you guys to work on homework in class except for the last 3 minutes. It is online though. All I have to do is on the book website is add this link. Okay? Any questions?